The
in
delta
terms of
H
everything.
specifically
Oh, and like
delta
in a
H.
reaction, like in terms of equilibrium, like where or how you know that's endo or exo or whatever.
Okay. I want to use an example that you guys actually had on your test, because I feel like this is one that's probably going to come up if I ever have a copy of it. There it is.
I have it.
All right. So this is from the FRQ that you all had, the second FRQ.
Okay.
It asks, hey, this actually it can go in two directions on this one. Look at parts B and C. Everything is based on reaction X, which is C, solid with water, which is going to produce carbon monoxide and hydrogen gas. Now, part B asks the question, and this is all based on the information you already have in front of you at the top. For reaction X, will the equilibrium constant Kp increase, decrease, or remain the same if temperature rises above 298 Kelvin? Justify your answer. If we're taking a look at the information for this reaction, what is our delta H value?
Delta H.
Yes.
Oh, for the Y?
For reaction X.
For X, it is 131.
Ooh.
What?
He's right.
Yes.
He's right.
Yeah. Hello, I'm correct.
Okay. Now, of course.
Schmidt, please call the phone office. Mr. Schmidt, please call the phone office.
Okay. Now, stop making fun of people when they make announcements, please. That's just not nice. Okay. Now, if we're taking a look at this reaction overall, what I want you to pay attention to is this. Our delta H value is
Positive.
positive.
Good job,
Is this endo or exothermic?
Endo.
How do you know? How do you know? Seriously.
Because that means there'll be an increase in heat and whatnot. You know what I'm saying?
So that means if I'm drawing out a diagram that looks similar to this, it's endothermic. I don't know exactly what the point is, but I'm going to make it this point. We're going to have our curve.
Yes.
And should we end above or below our starting point?
Above.
Above. Okay? Now, going back to your question, you said endothermic or exothermic overall.
Yes.
If I look up and I see that this is endothermic, that means I have to put energy in.
Plus, yeah. That's stuff.
I have to put some form of energy in to get the reaction going.
For endo.
For endo. Okay?
So the heat would be on the left side. The energy would be on the left side.
Yes.
Okay.
So that's like positive, but that's why H is positive.
Exactly.
Where did is that H2 on the far right?
Yes. Yes.
Huh?
Yes.
Where does that come from?
We're looking at it. Reaction X.
Okay.
So, if my understanding is correct, energy or heat is a reactant here. The reason why I said that this ties into, this question sort of ties into what you were asking. It asked the question, if the temperature rises above 298, which is where it said the reaction was happening as it was, what should we expect to happen to the Kp value? If I increase temperature, what's going to happen?
It's
Well, how does temperature or heat affect the equilibrium?
Was that right? Going up. Right. Well,
Keep going.
since the heat is on the left side, that means there'll be like the right side will be favored, will be product favored, I think. And
Say that one more time.
like since you're adding heat on that side, the reaction will move to the right.
Why?
Because it's trying to reach equilibrium again.
It's trying to reach equilibrium, but what is it trying to do with this energy?
It's trying to use up the excess.
It's trying to use up the excess energy that's coming in.
Wait, I had a question and then I lost it. Oh wait, okay. Does that mean that there's more products than reactant?
And if I increase the temperature, that means I'm going to increase my product.
In the diagram.
Huh?
In the diagram.
Does that mean that there's more reactants?
More products.
More products? Once I raise the temperature, you're saying?
No, in the diagram.
I know, I'm saying, are you asking me in general? Or are you saying, once I've increased the temperature, does that mean there's more?
In general.
This diagram wouldn't help you with that.
Okay.
This diagram is simply, this is the energy we started with, this is the energy I put in to get things going, and this is the difference between the two. That's it. It's not trying to tell you the amounts, how many moles you're dealing with, this is just the spectrum of energy.
So you don't have that diagram whether it's reactive favored or product.
Exactly. Now, if you're looking at it and you see this endothermic, most of our endothermic reactions tend to be reactant favored because again, I have to put in energy in order to get it to start. Grace, go ahead.
How did you get that as endothermic again? What specific?
Your delta H value is positive.
Okay.
Positive delta H means I have to put in energy.
Wait, what's delta
Endo.
H?
Enthalpy.
Oh, what does it mean though? Like,
Heat energy.
The amount of energy per mole that I would have to put in for the reaction. So it's the difference in energy from products to reactants.
Oh.
That also helps with another question. Why is my towel wet?
Oh, I was.
I didn't do it.
That just feels weird. No, it feels kind of weird.
No, because I use that spray.
difference in energy.
Okay. Yeah,
Is it safe to use?
that actually is another question too that we can sort of bring up. But was there another question before we go?
Yes. What information do you need to know if it's endothermic or exothermic?
They could give it to you as a diagram. They could give you, usually it's going to be a delta H value that you're working with. I've even seen a couple times where it was, the information was given in a little bit of a paragraph form. They still gave you the delta H, they just didn't write out the equation and write the delta H. Because I feel like part of the question was you actually had to write the equation.
Could you also tell by what side the energy?
Oh, definitely.
Okay.
Definitely. Now, for part C, for reaction Y at 298, the Kp value, is the Kp value greater than, less than, or equal to 1? Justify your answer. This is another one that really goes back to endo-exo. If we look at Y, reaction Y, what is our delta H value?
41.
Huh? 41. What is our delta G value?
29. What's okay?
Positive 29.
Right.
In order for the reaction to be spontaneous, or happen on its own, delta G has to be negative. So, if we're looking at it, delta G is positive, that means that it's going to be reactant favored. It's not spontaneous on its own. Huh?
If delta G is positive, it's reactive favored?
Yes, definitely. Definitely. There was one more question on there that I just, part D. This one shocked me a little bit. How do I find delta G? What is delta G overall?
Delta G
delta
equals
G
delta H minus delta S times P.
No.
Is it,
I appreciate you're trying to flip it
is it
around.
the Q1?
P times
No, simpler. Go simpler.
Wait, which one?
Delta anything is what minus what?
Change.
Final minus
Product.
initial.
Final minus
Oh, yes.
initial.
Oh,
So,
Energy, yes. Free energy.
delta H reaction equals H products minus H reactants, right?
Of course.
Yes.
Okay. If I have a positive value for delta H, which one of these is greater?
The products.
The products
Good
would be
job.
greater.
Yeah.
It would have to be because if I subtract from here and this is larger, I'll get a negative value. The reason why I ask these questions, I don't know how many people told me that for part D, for the reaction Y, which is larger, the total bond energy of the reactants or the total bond energy of the products? Explain. I had a bunch of people tell me it was the reactants. Okay? If I have a positive value out of delta H, it's the products that have let me down. Not really let me down, but you know what I mean.
G delta H right there.
Mhm.
So it's product favored.
Huh?
It's product favored.
No. It's still reactant favored. But the question is asking which one is going to have more energy. So if I'm looking at it, that would be another one where I could get that nice diagram. I have more energy here than I had here, so I have a positive value. If this was lower,
What does it mean when it's favored? Like,
It means in terms of the, I'll say-
Want to be more concentration.
it doesn't even have to really do with concentration. It's more so looking at the reaction at that given temperature, whether it's easiest to flow in that direction or the other. If I'm looking at a reversible reaction, based on how this is set up, right now, well, we just said it was reactant favored. So, which is more likely for me to see the forward reaction as we have it written or the reverse reaction? Which one do you think will be
Can
the reverse?
We just said that, but.
Because, yeah, I'm gonna get energy out of this. It's gonna be spontaneous in this direction. That would be more favored. This one, it'll happen. I can make it happen. I can put in energy, we kick it into high gear and we do it.
Oh, wait.
But
Wait, is it because the heat's on that side? So that if it goes this way, then you produce heat.
exactly,
So that's like, that's why?
that's part of it.
Oh, okay. See, that makes more sense.
Follow the heat. Follow the heat. That's just gonna make it. The amount of energy that goes out, that's what's gonna make it.
So favored is when you create the most energy.
Usually, yes.
So whichever side,
Entropy and energy.
whichever side the heat is on is the side that's favored.
Yeah.
More or less. That's why I said entropy and energy. Entropy and energy. All right. Next question. 'Cause I think we hit exo, endo, and exo pretty good. Are you good there? Okay, I got question and question.
Okay, so like,
Please stop blowing through the capital. Sorry.
Like, are there any sort of like trends that like we should just know? Because like a lot of questions were asking, raising like what would happen if we were to raise or lower the pressure or like change the size of the container or add like
Did it give you a reaction
wait, never mind. Those are like
and or information?
okay, never mind.
Yeah. Most of how I've seen the questions, you saw them on the mock, on both mock
Yeah.
exams, you should have. Here's a model, a reaction of something. These 5 questions go with that model. What if I did this? How would what if I changed this or did that? And looking at the results thereof. Britt.
What did you mean when you said follow the heat? What did you say?
She asked the question, is it more favored because heat is released on this side, the reverse reaction more favored because heat's released on that side? I said many times yes. So that's why I said follow the heat. If there's heat being lost in that direction, usually it's going to be more spontaneous in that direction, which would be favorable. And also, they may have it changed on the test. I'm trying to remember if they changed it from spontaneous to more product favorite, reactant favorite, that type of language, than just saying spontaneous, just so it's clear. And that way they also don't have to say forward, reverse too often.
oh man.
way. All right,
That's so rude.
Okay.
so, next question.
Does it have to be about equilibrium?
I prefer to hit equilibrium first. If we run out of equilibrium, we do what we do.
Okay.
Robert, you said you had questions, and then
Yeah.
do you still have those
Loud
questions?
and clear.
Yeah.
Would you like to ask those questions now?
Yes. So what's the difference between KP and KEQ?
Oh, yes.
One's dealing with concentration, one's dealing with pressure.
Which one?
But why is it
KP, pressure, KEQ or KC, concentration.
Well, KP is the pressure, like, it's like, it'd be like
Partial
the pressure of C and then the pressure of whatever.
Thank you for bringing that up. When I was grading this is something that, oh boy,
Wait,
my head was hurting.
I wanna know why mine's wrong though.
That's what I feel like I'm about to go to.
Okay,
I feel like I'm about to go to this, and I was very, very nice. If people got the point that they were supposed to be, what the correct species were, I think I actually gave it to them. If I'm trying to find KP, we said everything's done in terms of pressures, right?
Yeah.
If I'm looking at this reaction, how would I write the equilibrium expression?
I have no clue.
We know it's products over reactants.
the pressure of CO
Pressure?
times the pressure of H2. And then over the pressure of H2O. Yeah, sure. Oh, and C isn't included because it's a solid.
Thank you very
Oh,
much.
yeah.
I don't know how how many papers I looked at, and that was the first thing I looked at, and I was so upset because it was in both of the FRQs. Solid. Solids do not appear in KP or KEQ expressions. They don't appear in KA or KB or KW expressions, which we'll be talking about this week. Make sure it's only the gases, okay? Make sure it's only the gases. Another thing that goes along with this, for the first reaction or the first FRQ, another thing that sort of got me, I had a person who did this. Trying to make sure I have the right reaction, sorry. They took, there we go. They wrote it this way, K, and this one was also pressure. And they wrote,
No, that's incorrect.
what's wrong with that?
Everything.
Everything. Help
It's
me.
supposed to be the pressure
It's supposed to be
and
raised to
then
the power of 2.
the
not
moles
half the coefficient.
R squared, not everything.
Okay, so first, we gotta flip it. So I have carbon monoxide, carbon dioxide.
What's
Ray pointed out what?
It's supposed to be the pressure of,
Pressure of,
and then the moles R squared, not
which one?
the bottom, the top, wait, whichever one had the 2 on it, I forget.
You put the two on.
Yeah,
Originally I had it there, but it was wrong.
got it.
That was where it was flipped the wrong direction. So, looking at this, it should have been actually very straightforward. All you have to do, pressure of, square this one because it has a coefficient of 2, and pressure of carbon dioxide at the bottom. Nathan, yes?
What part of the question are we on right now?
That was a brief overview of part A on both FRQs actually. Looking at writing the KP expressions. Okay, I have a question. I have a question for you all. Everybody go ahead and look, since we ventured down this road. How would I calculate the number of moles initially in the container? Moles of CO2.
Wait,
Wait, which one are you looking
I
at?
didn't know that.
The first FRQ. I'm gonna leave this here. I don't really need it for this question, but I'm gonna go ahead and leave that there. This one was C solid plus carbon dioxide gas yields to carbon monoxide.
Would you use
Yes.
the molar math?
What did I tell you? If you're looking at pressure, what are they usually gonna throw out there? What do you have to be able to bring back if you're talking about gases?
PV equals NRT.
Ideal gas law.
Wow.
Where would I find out the number or the pressure that was originally in the container for carbon dioxide?
Okay.
In the chart.
Huh?
In the chart.
At what point?
Time 0 hours.
Time 0, correct.
Wait, say that again?
If you look at the question, right underneath it, it gives you the time in hours and the total pressure of gases in the container at 1,160 Kelvin.
Yes, but how do you use that?
How do you use that? If I say initially, that's going to be at what point? Time 0 tells me the pressure is 5 atmospheres.
Well, that's the total pressure. So how-
Yes, and what else is in there with it?
So you do.
Side, carbon.
That's it? So that's like,
So
I'm confused. Can you write this down, Mr. Goblin?
it's a solid.
it told me carbon is a solid. Does a solid have pressure
No.
No.
in atmosphere? No, not at all.
Wait, so 5 is just the total pressure?
The total pressure of carbon dioxide at the beginning of this whole process, 5
Oh
atmospheres.
my gosh, are you serious?
So, PV nRT. It tells me we're in atmospheres,
Because
and it gives me a temperature in Kelvin, so I know that I'm using 0.0821. And of course, I'll include the
Would that be
units.
in like a
how would you justify that?
Yep.
Oh,
It asked you about partial pressure. It gave you a specific gas and asked you how many moles based on the pressure that you have. It gave you a temperature and a volume of the container, which is 2 liters. So all the information, this is what you were looking at. 5 atmospheres is here. and temperature is
Are you serious?
1160 K. So that's why I said I think you have to get that practice of reading and interpreting the questions. The more practice you get with it, the more you'll be able to pick out the little things like that. Because majority of people, I think maybe only one person attempted this question. Everybody else just skipped right over it like, you know.
I attempted it, I got it wrong. I thought about it.
So, all right, if I was rearranging it, it'll be basically PV over RT equals N over 5 times 2 all over 0.0821 times 1,160. And your number of moles came out, I feel like 0.105, but I think I might be wrong. 10 divided by 0.0821 times 160. Yep, 0.105. I had several people change that. I had people who, I believe, tried to figure this out and they thought that they had to use the KP equals KRT delta N.
Yeah,
No question really required that. I think there was one where you could have possibly used it, but no question required that one.
Why'd you put it on the board?
I said I put all the formulas that you could possibly need. It's the same ones you would get if you had your reference sheet in front of you.
So, how are we supposed to tell which R we use for the constants and all these formulas and everything?
Huh?
How are we supposed to tell which R's we use for the constants?
Look at units. That's why I started off and I said it gives us the pressure. It says it's an atmosphere. It gives me a temperature in Kelvin. As soon as I see that atmosphere and the fact that I have a volume in liters, I know that I need to use the 0.0821. If I see that I'm doing joules, number of moles in Kelvin, like we were dealing with in Kp equals KRT to delta N, I know I need to use the 8.31 for that.
What's delta S?
Delta S, entropy.
Oh my goodness.
Questions?
Could we go on to C?
Part C for that one?
Yeah.
Okay, so it says, okay, all right, so it says for the reaction mixture at equilibrium. So we shifted our focus from the initial to the final equilibrium sort of setup. It says the pressure, partial pressure of carbon dioxide is 1.63 atmospheres. Calculate the partial pressure and then the value of the equilibrium constant. So I'm going to need that, so I'll keep that around. If this is my reaction, I had 5 atmospheres here, 0 here, this one is there. Something changed, something changed. I ended up at 1.63. What's 5 minus 1.63?
3.57.
3.37.
3.37.
Thank you.
So that means X here is 3.37, right? Right?
Yes.
Okay, so if this is minus 3.37, and this is plus 2 times that value, what's 2 times 3.37?
Wait, how'd you get to the?
How'd I get to this number?
Yes.
I know I started there. It told me at equilibrium I'm here.
How do you know? Okay.
Okay.
Since the reaction has to proceed this way first, before anything can really happen, that means whatever change I have, it has to end up on that side.
Wait, you can use that chart for pressure?
Yeah. It's the ice table is it's an ice table. Okay? Yeah, I want you guys, that's why we went through the examples. My hope was that you guys would realize it's, if you're doing an ice table, you're doing an ice table.
I didn't know you used it for pressure.
I don't understand why you use the ice table. What's the purpose
At
of it?
0.
So that I can figure out what the values are. If I can figure it out by simple subtraction, yay. If I have to go in quadratic, I can do it. Either way, I'm trying to figure out what that change is going to be. This one, I just subtracted to figure it out.
What just happened to x?
X here.
Uh-huh.
Well, since we subtracted and figured out what the difference was, I figured that was our X here. And whatever it was on this side, it had to be twice that on the other side. So it came out to be
See the change.
something.
6.67. The change in
Thank
between
you.
8.37.
4.
Okay.
6.67 with our,
Sorry, I'm stupid.
huh? 74.
6.74, I'm wrong.
Yay.
Yeah.
Okay, so now we have our partial pressure of carbon monoxide at equilibrium. If you wanted to check it, you could always add pressure here, pressure there. You should come out with the final pressure once it's hit equilibrium, which is 8.37.
That's what
And then
I did the opposite of that to get the partial pressure.
then all we have to do is plug in. So 6.74 squared all over 1.63,
Wow.
27 point
Whoa, whoa, whoa.
or 29 point something. It's one of the two.
You lost me.
So that's a.
Once I have these concentrations to find the KP,
Wait, what
I just plug
what
them
was
in.
5 minus 3.3?
1.63. That was what they gave me in the question.
Oh, okay, okay. And then, oh, then it's, okay.
27.9 and 27.887.
So 3.37 would be the change for both of them. Okay.
It's the change, it just affects this one more to preserve more ratio. But yeah. Questions, issues, major concerns,
Not
minor
major.
concerns, any concerns? Okay. I'm not going to delay that one any longer. So, other questions?
So 27.87 would be the partial pressure of CO2?
Technically, since they gave you 6 figs, I think they were looking for 27.9, but you're good. It's usually plus or minus 1 sig fig, so you're okay.
Like, how do you know when it's at equilibrium? It's the last value that they give you, right?
Notice they gave you 2 at the end that were the same. The pressure didn't change from hour 8 to hour 10. So that means you're at equilibrium.
And since CO2 is a reactant, you just know you start with that. You start with because you put 0 for.
Yeah, based on the information that they gave me, I only had info on carbon dioxide at the beginning, so
Wait,
I have to move accordingly.
so why would you use the pressure at the beginning instead of the pressure at equilibrium? Because you used 5 atmospheres, which is the pressure at the beginning. You didn't use 8.37.
Initial?
Wait, then when would you use the 8.37?
You don't.
You don't.
Why not?
You just.
You don't need to.
But it's an equilibrium.
Notice I said, when I add that and that, I get my 8.37. So I know that I've accounted for both my carbon dioxide as well as my carbon monoxide.
Okay.
But other than that, I didn't really need the 8.37.
Okay.
We're good?
Volunteer brownie.
Oh, you know it.
Yes?
And plus that stuff. Yeah.
Okay, so the only information they give me at the beginning is my pressure of carbon dioxide, right?
Yeah.
Okay. That means the reaction hasn't started yet. I just put something in the container. That's why I have the 5 here.
Okay.
Since I have no info for this, it's 0. Doesn't exist yet.
Okay.
Good.
Yeah.
Okay. Because of that, I know that whatever's happening when the reaction starts, something has to go that way.
Yeah.
Great. So, in that something going that way, I don't know how much it is yet.
Yeah.
So I'll put X.
But you know that it's gonna be smaller. You know that you're gonna.
Smaller than what I had, yes.
Yeah.
And I know it's going to be negative because it has to go that way.
Yeah.
Okay.
Wait, how do you know it has to go that way?
I had a 0. I had none.
How did you
So-
know that there was a 0?
It didn't give me any information about carbon monoxide. It just says at the beginning of the reaction, these are my conditions. Okay? Now, according to the equation, it's a 2-to-1 ratio. Well, 1 to 2. One of these, 2 of those.
Yeah.
So whatever the change is for this one, is going to be twice as much for this.
Yeah.
So that's why this was 2x.
Okay.
Negative 2x?
This is positive 2x, that's minus x.
Oh, okay.
Now, in part C, it tells me at equilibrium, this has a pressure of 1.63.
Okay.
So if I started here, and when I get to equilibrium, I'm here, that's a difference of that, 3.37.
Yeah.
That's my x.
Okay.
So then I take this number and multiply it by 2 to get the concentration I have here.
Say that last one again.
Since I know that this is the change,
Yeah.
and the ratio is 1 to 2,
Yeah.
since this change, this was x, 2x is going to be 2 times that same value.
Yeah.
When I multiply that, that gives me my equilibrium partial pressure of
Okay.
carbon monoxide.
All right.
Wonderful. Where you did like one of these, like, okay. Questions, issues, major concerns, minor concerns?
Can you explain E?
I probably could. The question is, do I want to?
Ooh.
All right. It says, in another experiment involving the same reaction. In another experiment involving the same reaction, a rigid 2-liter container is
No,
initially
for
contain-
question 1.
Question 1.
Predict whether the partial pressure. Oh, wait, okay. Got it.
Okay. What is a rigid 2-liter container initially contains 10 grams of carbon plus carbon monoxide and carbon dioxide, each at a partial pressure of 2 atmospheres at 1,160. Predict whether the partial pressure of CO2 will increase, decrease, or remain the same as the system approaches equilibrium. Justify your predictions with a calculation. So it's saying same reaction, same temperature. We already have a Kp value. What was our Kp value again?
27.87.
This is our Kp. It gives me the equilibrium concentrations of what was just put in here. It says 2 atmospheres of each, right?
Yeah.
Okay. So, Q, actually let me bring this to the center of the board just in case, make sure it's visible. I can get rid of this stuff, right? I was already getting rid of it even as I asked them. Alright. So to check it, I have to do a Q calculation, reaction quotient. So 2 squared over 2. Because it told me both concentrations were 2. Or both pressures were 2, sorry. 2 squared divided by 2 gives me? 2.
Wow.
Alright, I have a question for you.
Yeah.
Is Q equal to, less than, or greater than K? Less than. Which way is the reaction going to go?
Right.
It's going to go to the right, which means our concentration, our pressure of carbon dioxide is going to
Q is less.
It's less than decrease.
Oh, I see
decrease.
now.
Wait, can you say that again? What's going to happen?
Q, in this case, based on our values, our Q of 2 is less than our K, which is 27.9. Therefore, the reaction is going to shift
Alligator.
to the right, eating that side.
And where did you get all the 2?
Containing 10 grams of carbon plus carbon monoxide and carbon dioxide, each at a partial pressure of 2 atmospheres at 2,160. Hasta mañana.
So, partial pressure of CO2, since it's going that way with.
And this is the forward reaction, that means it's going to decrease.
Oh, it's going to decrease?
Yeah.
Wait, how do you?
Because I have to use Q is less than K, which means the reaction is going to go, to reach equilibrium, it's going to go to the right,
Oh, it's a decrease.
which means this is going to get used up as it goes to the right.
Oh, light bulb.
There we go. That's the Baldwin advantage. No, I'm joking. So, it's okay, you'll see it on the video later. So, questions other than that? Oh,
Oh, bondage. Yeah. Oh, bone coverage.
Oh, I get that.
so we're good? Everybody's just in snacking mode? Okay, wonderful.
No.
Wait, I'm gonna find questions on the test now.
We're gonna find questions on the test. I thought these were on the test.
No, like multiple choice.
And those I would prefer if you did with your research
Oh,
and resources.
okie doke.
The FRQs are, they're using the same information, but it's usually putting things together. I don't mind being the bridge to help you put the things you know together. But those, yeah,
Mr. Ball, I'm gonna get practice for kids.
yes. You're gonna get lots. Oh, I erased it. Notice it was 2 days FRQs and then 2 days practice test. Oh, yeah. But I was told that Learnerator has a lot of other FRQs just in case you want to get a mixed approach. Huh? Should I stand in front and dance?
Macro and micro.
Macro.
Big.
Micro.
Small.
Like Nathan?
Macro, micro.
Ooh, you know, I got that one wrong on the
Yeah,
study guide.
microscopically small children.
Mm,
What's static and dynamic?
okay.
Yeah, what is that?
If I'm looking at, this is one we actually talked about at the beginning, and I think this will help with one of the things Robert was saying earlier about equilibrium in general. If I look at a reaction in a container at equilibrium, unless there's some kind of significant color change or something like that, it's going to look like nothing's happening.
Okay.
That's my view macroscopically. So it's going to look like it's macroscopically static. Nothing happened. But if we're able to get down to the microscopic level, to the molecular level, there's still all sorts of things happening because the reaction is going forward and reverse at the same time. Forming products, breaking them down. Forming, breaking. Be microscopically dynamic.
On this second FRQ,
Uh-huh.
why did they give you the change in energy, like free energy and entropy?
Because you could use those as justification for other parts of the question. Like we did for part C, where we looked at the delta G value as positive. That means it's non-spontaneous.
Right.
So that like those little things give you insight into how the reaction is going to go.
Alright, so if we look at F for that number 2 FRQ,
Mm-hmm.
how do you do that?
Okay, it says reaction Z. Is delta S, or entropy, going to be positive, negative, or 0? Justify your answer.
Entropy, is that stress or temperature? Stress.
It's disorder. It's disorder. So,
Wait, and how's that measured?
huh?
How is entropy measured and what? I know.
In what units?
Yeah.
It's actually on there. It's kilojoules per mole.
Oh.
Yeah.
Wait, so like positive?
Oh, sorry, wrong one. Haha. Joules per mole Kelvin. Sorry. I deeply apologize for that. All right, now, if I'm looking at the reaction, because it kind of technically brings in some Hess's law stuff while I'm not really trying to. If I look at reaction Z, it takes parts of reaction X and Y.
Yeah.
This is what we're trying to end with. 2 carbon monoxide, gas, yields carbon solid, and CO2. I have a question.
What?
Probably not.
Probably.
Solid.
In the previous, not even that. That is going to play a role too, though.
The proton.
If I'm, all right. If I'm taking a look at this, if I'm taking a look at carbon in this case, solid carbon, in the previous reactions, X or Y.
It was a reactant.
What?
Thank you, Parker. You answered the question. Yes. If you look at reaction X, solid carbon, and reaction X was a reactant.
Yes.
Here, it's a product.
What's
What does that mean we have to do with the sign?
Oh,
We have to get the inverse. Like we have to.
We have to flip the sign.
What's up?
So, we're going to take what was once positive 131, because we're looking at it in the opposite direction. which changes the sign, oh sorry, 134, is gonna become negative 134.
Oh, is that easy?
That's it? Is that?
What's up? That's cool.
And then, what is it? For reaction Y, you're gonna have to double the value because you need 2 moles of carbon monoxide, and right there you only have 1. So overall, it was just asking you to justify whether it was positive, negative, or equal to 0. Because you flipped the sign of the negative 134, even with doubling your, what is that thing called, your Y value, your delta S for Y, you're still going to end up with a negative value overall.
So would it be the same thing if it was a product and then a reactant, you still keep the sign?
Yes. Now, the other thing that you could have looked at, which is where I thought most people would have went immediately, is what do we know about the entropy of solids?
Very low.
Very, very low.
They usually, yeah, very low. So if I'm going from a gas to a solid, even though there's another gas here, a lot of the entropy is going to be into getting that down to a solid. So it's going to be a negative value overall.
How would you do part 2?
Part 2, determine the delta H. I actually kind of explained that a little bit. Actually, I don't have to double it because there's carbon monoxide in both. It gives me the delta H for the first one, which we already said we're going to have to flip, so it's negative 131. And then that would actually cancel out, so I do have to double one of them. I believe it's going to be minus an additional 42. The answer was 140, 145, 146, something like that. Or 150 something, sorry. No. Yeah.
Wait, what do we double?
If I'm looking at, if I flip this reaction to get what I was talking about, I'm going to have CO2, or not a CO gas, plus H2 yields H2O plus C, solid. This one's going to hold exactly as it is, CO2. Nope, that one has to be flipped too. The carbon dioxide one has to be flipped as well. Yeah. So it's going to be CO plus H2O.
So you flipped both reactions?
Yep.
Okay.
Wait, what?
I had to flip both reactions.
Why?
Carbon dioxide in this one. Carbon dioxide in this one is a product, but up here it was a reactant.
Okay.
So
Okay,
Wait,
okay.
is this still for 1?
no, two.
Okay.
And this one is, what am I
For
last
which
thing I said?
reaction?
H2.
H2, yeah.
This will give me my 2 carbon monoxide. Both of those are here. My carbon dioxide that I needed, and my solid carbon. So all I'm really doing is flipping the sign on the delta H's.
Okay. So negative 131 and negative 141.
Well, no, 141
Oh, I said 41.
minus 41.
And that's it?
That's it.
Okay.
What part was that?
That was part F2. This number minus that number, which will give you a thing, which is negative 172.
Wait, where's the negative 41?
I had to flip this one
Oh,
too.
wait.
I had to flip both.
Delta
So-
S for,
So you want to like just get the products like matched up pretty much?
for delta S on part 1, you said you just made it negative because in
Going opposite direction.
the reaction to X, it was in the opposite direction. It was a
Still the same.
So you just made it negative. It's that simple.
You just have to flip
How would
sign.
you justify that?
How would I justify that? Again, before I had this reaction, this first reaction, as if it was going the opposite direction where carbon solid was a reactant. According to what I'm looking for, I don't need it as a reaction. I need it as a product. So that entropy change is going to be the same either direction.
Okay.
So that's why I flipped it, which allowed me to flip the sign.
And for part 2, what did you do? Because I missed part of that.
Part 2, I saw that in order to get this, I had to flip both reactions. Because 2 carbon monoxide is what I needed, right? And I needed carbon dioxide as a product. In order to do that, I had to flip this reaction, and I had already flipped that one. So then I just took the values that I was given according to the thing, which was the 131, which became negative 131. And since I flipped the other one, which was originally 41, it becomes negative 41. And I'm just going to combine them.
Okay.
So like the hydrogen has like nothing to do with it.
Nothing at all. It just sits there.
Right.
Just sits there.
It's not very helpful.
It's a spectator, right? Yes.
Oh,
Yeah.
you go.
Nathan, you're doing something today.
Give the man a cookie.
Keep going.
All right.
Don't.
What time we got?
3:25. 3:24.
3:24? Can we get one more question in time, or are we done?
Can I know how
Is
you
that
want
kind
to
of
do,
our
how you want us to do the questions? Like,
How are you going to turn it into me?
yes.
Okay. Now, this is for those who are sitting in the room and those who may watch this video at another point. Because in 6th period, well, Rajiv heard me.
What?
I was quite frustrated with the person. Kimara heard me because
Who were you guys?
they had a misconception of what I was looking for.
What happened?
When we do test corrections, and I say this in the nicest way possible, I don't care why you chose it. I care why it was wrong.
True.
Okay? And I don't want that to seem like I don't care about you or what you think. No. What I'm looking for in this is I want you to figure out the reasoning behind why that answer is wrong so that you don't do it again.
Oh.
Not, oh, well, I was rushing through and I just chose. It doesn't help me and it doesn't help you.
What if you just guessed?
Exactly, and that's the other thing. If you guess, then you write, I guess. Technically, you could write, I guess, for all of them. Be like, haha, done. No, that doesn't work. Okay? So instead, what I need from you is, this one you chose. Whether you guessed or you had a logical explanation, why is that a bad choice? For the correct one, justify. It's correct because, and then give your information behind it. I haven't gone to the level of some teachers who tell you they want book or references from where you got it, okay? Because there's some who tell, like, if you use your textbook, they want to know what page. I'm not going that deep this time, okay? I haven't got to that level yet. But I need to know, why was the one that you chose wrong? Why was the correct one correct?
How would the format of it be? Like, would you just like write the one you put and then like, would you want us to write a question?
I got number 1 incorrect.
Okay. Yeah.
I would say I chose A.
And why?
A is incorrect
Okay.
because.
Okay, cool.
And then the correct answer was C.
Okay.
C is correct because. And give your justification. One of the things I want to make very clear, I know a lot of people hate details and hate explaining.
That's what it's all about.
But, like I said in class, the FRQs, there's an implied why and how in there, okay? So if it asks you to explain, or even if it doesn't ask you to explain, there's certain things they're looking for. So don't like put decreased.
So put it as much as you can, right?
It's like it decreases because. Give the justification, give them a reasoning to go off of. Give me a reasoning to go off of. That way I can tell whether you guessed at it or whether you actually understood it. And again, most of the questions for the FRQs, some people missed it because it's 1 point for answer and justification. They just wrote an answer. Yes, Grace.
So when are these test corrections going to be due?
Wednesday next week. Wednesday next week.
So many students.
Something like that, yeah. 22nd.
Would you be willing to go over some of the questions from the FRQ on the mock?
I would love to. Just can't do it today. Because 3:30 we said is our cutoff. That's the only reason why. But if you're gonna be, we still have to figure out when you're gonna do your test and whatnot, right? So see me so we can work out when. I would love to actually take our mock info. It just depends on who's here, because I have 2 people who haven't taken it, and I hate to be like, yeah, and the answer is, and they're like,
Ooh, right.
oh yes, thank you. Okay. Yeah, but I have no problem doing that. That would actually bring me great joy. Cool.
Are we gonna go over the mock in here or in class?
Here. It's going to be in this type of setting. Unfortunately, you saw our schedule. We really don't have time. We really don't have time. The question was, actually, that would actually, if we, because the makeup day is the 22nd, which is next week, Wednesday. That would give us 1, 2, 3 possible opportunities to go over the, regardless, the mock exam. If they don't do it by then, they got to work out something else. I don't know this. Okay. All right. So, thank you for flying Baldwin Airways. See you all tomorrow in class. Have a great day.